Okay, let's take a look at some rules of exponents. First of all, we're going to look at some patterns before we go ahead and start right into the rules. So for this, if we're multiplying 2 to the 4th times 2 to the 3rd, 2 to the 4th is 2, 2, 2, 2, 2 to the 3rd is 2, 2, 2. So we have 7 total factors. Another way of writing 2, 2, 2, 2, 2, 2, 2, each of them being multiplied, is just to write 2 to the 7th. So let's see here. 3 to the 1st is 3, and 3 to the 4th is 3, 3, 3, 3. So I end up with 5 factors, and I could easily write that as 3 to the 5th. Or here, we have 5 squared, which is 5 times 5, and 5 times 5 to the 4th is 5, 5, 5, 5. So I end up with 6 factors and gives me 5 to the 6th. The conclusion that we see in class is that really we could skip this whole middle part and say when you have the same base, all you're going to do is add the exponents. 4 plus 3, 7. 1 plus 4, 5. 2 plus 4, 6. So that's what we conclude. When you have the same base and you're multiplying, add the exponents. Now with quotients, same thing, similar pattern is going to present itself. 2 to the 8th over 2 to the 3rd. So we write out 8 2's and 3 2's. Now we know that if it's in the numerator and denominator, it cancels out to just give us 1. So the only thing we're left with is 2 to the 5th, which is what we write here, our simplified expression, 2 to the 5th. So next one, 3 to the 5th. So it's 3 times 3 times 3 times 3 times 3 divided by 3 to the 3rd. 3 times 3 times 3. When we cancel out what's in the numerator and denominator, we're only left with 2 3's. So 3 times 3 is the same as 3 squared. And the last one, 5 to the 7th. So I'm going to have 7 5's. 3, 4, 5, 6, 7. Divided by 6 5's. 1, 2, 3, 4, 5, 6. Now if I cancel out what's in the numerator and denominator, pretty much cancel out everything. The only thing I'm left with is 1 5. So it's 5 to the 1st. So the pattern here is that if you have the same base and you're dividing, you're going to subtract the exponents. 8 minus 3, 5. 5 minus 3, 2. 7 minus 6, 1. Okay? So if we go on to the next page, we're going to see that these are actually properties. Product of powers property says to multiply powers with the same base, add their exponents. So let's try some. My base here is 2 and 2, so we have the same base. All I do is add the exponents. 3 plus 2, 5. 2 to the 5th. My base here is A, and A, so I'm going to add the exponents. But don't forget, if there's nothing written there, that's really like an exponent of 1. 1 plus 5 plus 2 is A to the 8th. Now here, we actually have the same base, so be careful. My base is M. 2 and 7 are just coefficients. If I have 2m to the 7th, that's my exponent, that's my base. This is just a coefficient, and the reason is because this 7 is only affecting the thing right in front of it. So here, what I can do is just focus on the m to the 7th and the m to the 5th. I'm going to write my base down and add the exponents. I get m to the 12th. Now I can go back and look at these coefficients. Because we're multiplying, all I have to do is multiply. 2 times 7, 14. And that's what I get, 14m to the 12th. Letter D, same case. I have the same base, which is x. So I'm going to take care of that first. X, and I'm going to add the exponents, x to the 14th. Now I have these coefficients, 3 times 5, so I multiply and get 15. In letter E, I have the same base of y, so I'm going to write y down, and I'm going to add 3 plus 2, and I get 5. I'm pretty sure that's a 3. 3 plus 2, I add my exponents and get 5. Now that I've taken care of this product of powers property, I can just multiply like normal to 2, and then that's a coefficient of 1. So I get 2y to the 5th. The next one, I have the same base of, oh actually I don't. This one is x, this is y. If I don't, the reason this one's on here is to show you that if you don't have the same base, there's not really too much you can do. That just stays x to the 4th, y to the 3rd. The only thing you could do would be to multiply the coefficients, because as we saw above, those are kind of separate. So 10 x to the 4th, y to the 3rd, that's as far as you can go. You can't combine anything else. Now the quotient of powers property says what we saw before. If you have the same base, you're going to subtract. To divide powers with the same base, subtract the exponents. So 7 to the 5th over 7 to the 1st. My base is 7. I'm going to subtract 5 minus 1 to get 4. Letter B, I have z to the 8th over z to the 3rd. So z is my base. I subtract 8 minus 3 and get 5. Letter C is like we saw above. We look at our base, which is n, and we take care of that first. So I have the exponents 5 and 2. I'm going to subtract 5 minus 2 to get 3. And now I can look at the coefficients and simplify. 8 divided by 4 is 2. Letter D, x to the 7th, x to the 3rd. I have the same base, so I subtract and get x to the 4th, subtracting my exponents. And now I just want to simplify. 12 over 8. Well, that doesn't divide as nicely as this did, but I can reduce it. 4 goes into 12 3 times, 4 goes into 8 twice. So 3 over 2, x to the 4th. Letter E, y and y, so I'm going to, my base is y, I subtract the exponents, 5 minus 1 is 4, and then I'm going to divide the coefficients. 7 divided by 1 is just 7. And letter F, my base is n, so I subtract 3 minus 2 and get 1, and now I can focus on the coefficients. 25 divided by 5, which is 5. Alright, now we have one page left we want to look at, and this is where we're going to pull it all together. So we're going to have multiplying the numerator, and then we're going to have dividing eventually when we have everything simplified. So first step, simplify the numerator. So I'm just going to look, I have a to the 4th times 10a cubed. So my base is a, so I do that, and I add the exponents, 4 and 3, and get 7. Now I can multiply 1 times 10. When I do that, I get 10. Now I simplify denominator. There's nothing really to simplify, just a squared. So my last step is to simplify the entire expression. My base is a, so that comes down. I subtract 7 minus 2, which is 5, and 10 divided by 1 is 10. That's my answer, 10a to the 5th. Letter B, focus on the numerator. You're going to add the exponents, so b to the 8th, and then you multiply the coefficients. 14 times 2 is 28. In the denominator, there's nothing to do, so we just bring that over, and now we simplify. B to the 8th over b to the 1st, same base, so I subtract the exponents, and then I work with the coefficients. 28 divided by 1, 28. 28b to the 7th is my answer. In letter C, I'm going to go ahead, add y squared, do 2 plus 8 and add them, because we were multiplying, we have the same base, and then I multiply 12 times 1, just get 12. And that's all over 16y to the 5th. So now I'm going to simplify. I have the same base, so I subtract 10 minus 5 and get 5. And then I simplify 12 over 16. 3 does not go into it. 4 goes into 12 3 times, and 4 goes into 16 4 times. So my final answer is 3 over 4, y to the 5th. Okay, moving on, we're doing great. Numerator again. G to the 5th, g to the 3rd, that gives me g to the 8th. Now I multiply 12 times 7 and get 84. All of that's over g squared. So now I'm dividing, so I have to subtract the exponents. 8 minus 2 is 6. And I divide 84 divided by 1 and get 84. Letter E, h to the 8th, h to the 3rd, gives me h to the 11th. And now I work with the coefficients. 7 times 8 is 56. All of that's being divided by h, so when I subtract my exponents, I get h to the 10th, and I divide 56 by 2 and get 28. Letter F, you're going to add, we have y to the 1st, y to the 8th, so I get y to the 9th, and I multiply 3 times 1 and get 3. In my denominator, I have 15y to the 5th, so now I just have to simplify. I have the same base of y, so I do 9 minus 5 and get 4, and 3 over 15 can simplify to 1/5. 1/5 y to the 4th. Okay, if you wanted to practice a few, here are the steps. This would be r to the 8th over r squared, which gives you r to the 6th. This is going to be 24 g to the 8th over 16 g to the 4th, which is going to reduce to 3 over 2 g to the 4th. And this one is going to give you 28d to the 8th over 7d squared, which when you reduce and simplify gives you 4d to the 6th.